So let's continue with quality. The next thing that we want to look at is cost of quality. Cost of quality is a big thing in most companies simply because they're paying anyways their employees and paying for all the materials to make this product. But then if the product is something is wrong with this product, nobody's going to buy it. So there is a cost of quality as well, right? So one of the quality cost is the appraisal cost. The appraisal cost basically is the cost of inspecting, testing, another task to make sure that the product is acceptable to the customer. There is appraisal cost. So when you make a product, they're going to look at it from various angles to make sure that the product is good. There is appraisal cost. In order to prevent defects, there is a prevention cost. If there is a failure, if there is like any other failure inside the company, there is cost as well. Most of the cost of defects incurred in this area of internal failure is scrap, rework, repair, and those kind of things. External costs or costs of defects that pass through the system but detected by customers. This might be very costly simply because the customer may not buy another product from your company. So this is of great importance as well. Quality is so important that there is an international organization called ISO. And this international organization for standardization started in 1987, and it is recognized in every country around the globe. It's a prerequisite for any type of product. There are different standards within this ISO organization or International Organization for Standards called ISO. There are various standards. There are standards which are like, for instance, Standard 9000 is a common thing. It basically tells you that document what you do and then do as you document it. Very simple. But if companies can follow that, it becomes a process. And this process is going to be done over and over again using the same documentation. So it is going to be the same thing. So if you have a perfect product and you document it, and you can do the same perfect product over and over again, right? And that's what ISO 9000 does. So you need to get certified in ISO 90,000 or 14,000 or whatever the number is. So certification is done in various forms. First, the first party, that is the company itself, they audit, make sure that everything is correct. Then a customer audits the supplier. And then you have a totally different agency serving as an auditor to make sure. That is a third party auditing. So first party, second party, third party auditions should be done, and those audits will lead to a certification. So you can now say my company is certified in ISO 9000, which is great simply because everybody knows that your products are quality. So there are different ways that you can look into ISO 9000 and ISO 14000 and all that. The main thing about ISO 9000 in the quality management principle is basically it's focused on the customers. And it is a very process-oriented approach. And usually you're looking for continuous improvement of the product. These three things are the focal point. Then there are other things like leadership and beneficial supplier relationships and better decision makings and things like that. So each one of these quality standards, ISO 9000 or 14,000 or 26,000, has their own principles, and the companies have to adhere to these principles. Companies also look at other companies, and they do what is called benchmarking. So if I have in my industry the best performer, for instance, let's say Ford is Ford cars are the best among the three cars that is made here in Detroit, then the Chrysler or General Motors is going to look at Ford and say, wow, these cars are pretty good. I'm going to make sure that I'm going to compete with them. And then I'm going to go to the company and then find out how they make the cars. Is there any way that I can do that? That is called benchmarking steps. So many companies allow this benchmarking because it is going to give them the reputation also. So then they give you the data, you can analyze the data and then see how to bring about your own product as the benchmark product. The next thing I'm going to talk about is called Six Sigma quality. Six Sigma quality is a philosophy. It's also a method. These methods or philosophies are used by companies to eliminate defects. That is the whole idea, is to eliminate defects. How do you eliminate defects? You reduce the variation in the process. You want the process to be perfect. It is going to, if you want to make these pens, the process has to make perfect pens. So the process should be perfect. And if the process, something goes wrong with the process, then you have defects. Okay? Six Sigma is a statistical term to describe the quality, and the quality is the goal. And basically, you want to have no more than 3-point defects out of 1 million units. That is awesome. If you make 1 million pens and only about 3.5 of these pens or 4 pens are bad, this is great. Or if some defects, not even bad, they are defects, then this is great. Your process is fantastic. You're making perfect pens. Okay? How do you calculate these? There is something called DPMO which you can calculate. DPMO is the number of defects. So you take number of defects in pens and you take the number of opportunities for error times the number of units you're making and multiply that with 1 million. And that gives you the DPMO, or the defects per million opportunities. Okay, so this DPMO is a metric that is used to describe the variability in the process. Six Sigma methodology was discovered at Motorola in Chicago, and Motorola actually used the Six Sigma to make sure that their products are of quality. And after that, many companies started following. General Electric, General Motors, Honeywell, Ford, every manufacturer followed that Six Sigma. Now, even banks are following Six Sigma. Financial institutions are following Six Sigma. So Six Sigma is a big deal in most of the companies. They want to make sure that there are no defects. In a bank, you can say that I want perfect checks to be checked out. So if I write a check and the bank is looking at it, they want to make sure that they look at it thoroughly and make sure that the check is correct in all ways. So there's no defects in the checks. Simple things like that. So it was actually developed by Motorola, but General Electric actually took over and developed it a little more. Okay, in a method, actually as a method. A Six Sigma program seeks to reduce the variation in the process that leads to these defects. There are different tools the Six Sigma guys use. They use a flow chart, they use run charts, and all that stuff. Let's go through a few of them quickly. A flow chart basically is this. So basically, you take the process steps and then go through the whole thing. If I want to make, for instance, this is for making making copies in a copying machine. So for that, there is a process, right? So the process is going to be put the original on the glass, close the lid, adjust the settings, press start, remove the originals and copies. That is a very simple process. So this is a flow chart of those processes. Okay, this is a flow chart of that process, basically. If I have this process just on top of the copier, anybody who doesn't know how to copy can pretty much copy it. Okay, that's the whole idea of these processes. Next thing is a run chart. Run chart basically gives you a running total of all the things that you've done. For in this case, they're talking about deliveries, and from month to month, what are the deliveries, and that is the cumulative effect of all these deliveries. So you can see that the deliveries increased till about July, and then they decreased after that. This is the average monthly volume of deliveries per shop. So you can see from the picture itself that something went wrong in July. Maybe it is a seasonal effect. Maybe the company started making poor quality stuff. Or something was wrong with the delivery system. Maybe the customers are buying. So you can find that, hey, something is happening here. That's the whole idea of a run chart. Check sheet basically gives you this. So if I do something, I put a check. If I do this again, I put another check. Third time, fourth time, fifth time, sixth time, seventh time, eighth time, so on and so forth. So you can count the things that you want. So here you have a Wendy's operator, and looking at Wendy is the operator, and she is looking at various reasons and that is going on with the machine, and she is checking the frequency of all that. Using these frequency, I can make a Pareto chart. The Pareto chart is a frequency chart, and it basically tells you the highest frequency to a lowest frequency. That's what it does, a Pareto chart. This is a cause and effect diagram, which is called the Fishbone Diagram. Here, this is the problem, and these are the causes. It looked like a fishbone. That's the idea. That's why it's called a Fishbone Diagram. So you come up with the problem, and you come up with various causes. For instance, late pizza deliveries on Fridays and Saturdays. It might be because of the people who are delivering it, because of the equipment or machinery that you have, because of the process or methods that you are having, and maybe because of the materials itself. So for instance, people, you can say, people are not showing up, customers are not showing up. Why? Because, the guys who are making pizza are not showing up. Why? Because there's no teamwork, there's no training, because of low pay, high turnover. All these are different causes of late pizza, basically. So you come out with this, and then you hone in on which is the best thing. Maybe this is the main problem. So you come out with the problem, and this is where the causes are. And then you go to the right cause. Maybe we need to have training so that people can do a better job. That might be the real problem, and that might be the real cause. So you really want to take your people and train so that you can have better pizza deliveries, not late pizza deliveries. A process control chart is what we are after. A process control chart always have a mean, the average, and it has an upper control limit and a lower control limit. The data falls within these. If the data goes above or below the LCL, there is a problem. Here in this chart, all data is between the control limits, so everything looks great. But sometimes this point might be here. Then there is a problem. There's a problem with the process. So I need to check why this is happening. And that is the whole idea of a process control chart. We will be doing an X bar chart and an R chart in a few minutes. Statistical quality control is something that we need to look at next. Statistical quality control tells you the quantitative aspect of quality management. It tells you what is a variation in the process. It tells you what are the assignable variations, what are the common variations. Assignable variation is caused by factors that can be identified and managed, whereas common variations is something inherent to the process itself. So we need to look at what are the assigned variations and the